We're going to go ahead and take a look at number 60 from section 10.4, which deals with graphing of quadratic functions. Again, this is an application problem, so if you don't have your book with you, I strongly suggest that you pause the video to grab it so that you can read along with me and start picking out important information. So go ahead and pause the video and grab that for me. Okay, I'm assuming that you've unclicked pause and now we are ready to engage in this problem. So with this problem, number 60, it's fencing a field. So a farmer wants to fence in 3 sides of a rectangular field. So I'm going to make the fence this brown color. And he's only fencing in 3 sides because the other side of the rectangle will be a river. So I guess he's hoping that his cattle don't want to go swimming. Okay, if the enclosed area is to be maximum, find the dimensions of the field. So essentially, one of the key words that you should be taking away from this is the idea of area. And what is the area of a rectangle? How would you calculate that? Think about it for a second. Hopefully you're thinking something along the lines of length times width. Okay, so let's go ahead and use some other information that we have here. I know that I have, 1,000 feet of fencing. So that means if I were to measure from this point of the river along this side to down here, all the way to this third side, I would have used 1,000 feet of fencing to create those 3 sides. Okay. So do I know what this is? No. So I'm just going to go ahead and say that that's x. So since this is a rectangle, opposite sides of a rectangle are identical, so the other side must be x. So then my question is, well, okay, if I know that if both of those sides are x, what is this third side? And actually, I know that I used a total of 1,000 feet, and I'm just going to subtract 2x from it. Okay, the 2x is representing the x value here and the x value here. I'm taking 1,000 and I'm subtracting off the 2 sides that I've already denoted as x, essentially. Okay. So from here, let's see here. We are going to go ahead and start working with area. Okay, so in this case, I know that my area is equal to the length. So we'll say that the length here is 1,000 minus 2x times the width, and our width is x. Okay. So if we go ahead and clean this up, we would distribute that x to each term. So this gives me 1,000x minus 2x squared. Okay, so notice if I rewrite this, then you'll see that this is 2x squared plus 1,000x. I'm taking care to show you that the negative sign in front of your term follows it when you manipulate it around. Since this 1,000 is positive, that's why you see a plus sign here. Okay. Again, we can use our shortcut then. So x is going to be equal to negative b over 2a. The reason being is because notice that the highest degree here is a square. So that means that this is going to be parabola in shape. It will be opening downward because you have a negative attached to your leading coefficient. So my b in this instance is going to be, oops, see I made a mistake there, I'm sorry. That should be 1,000. So this should be negative 1,000 over 2 times negative 2. So this becomes negative 1,000 over negative 4. And then this will equal 250. Okay, so recall then the question for this problem is if the enclosed area is to be maximum, find the dimensions of the field. So I know what x is. In other words, I know that this width is going to be 250 feet. This will be 250 feet. And then in order to calculate the length, I would do 1,000 minus 2 times, I know now that x is 250. So this is 1,000 minus 500, or in other words, this is 500 feet. So the dimensions of this area right here, this fenced-in area, it's going to be 250 feet by 500 feet. And there is your solution highlighted in green.